All right, this is your problem of the day. You need to determine whether the ordered pair is a solution to the equation. All you really have to do is plug in 3 for x, 2 for y, and see if that equals 6. So on that first one, you take 4 times 3, which is 12, minus 3 times 2, which is 6. 12 minus 6 is 6. So that one would be a yes. Continue that on. Number 2 is a no. 3 is a no. 4 is a yes. 5 is a no. 6 is a yes. What we're going to be doing today is determining the solutions of linear systems. So we're going to be doing a lot of 3-variable systems here. This is kind of some hints on what to do. You might want to pause and read this or write some of those down in your own words. So on the first one, example, we've got 4x plus 2y plus 3z equals 12. That's equation 1, equation 2, and equation 3. I'm not going to read each one of them for you. You can do that yourself. But what I notice is each equation has an x, y, and z. So first thing I need to do is rewrite the system in 2 variables. So it looks like we took equation number 1, and sometimes I'll even write a 1 right there, and it looks like that is equation number 2, and what we did was we multiplied that by 2. And that's where the 12x minus 2y plus 8z minus 6 comes from. The reason that we did that is we're trying to eliminate our y's. We created opposite coefficients there. Add them together and you get 16 plus 11z equals 6. So we need another equation. So on this one, we have equation number 2. This time, though, it looks like we took that equation number 3, and we multiplied that by negative 3. That gives us a negative 18x plus 3y minus 12z equals 9. Again, our whole goal is to create opposite reciprocals. We're trying to eliminate our y's. So now we have negative 16x minus 7z equals 2. So that is our new equation. So we have that equation and that equation. And that works out really well because if you notice, the x's are opposite coefficients now. So now we're going to solve those. Add them together. 4z equals 8, or z is going to equal 2. Once you get one of the variables, it's going to be a lot easier to solve. So then all you did was take that 2 and plug it in to one of your equations, either your new equation 1 or your new equation 2. So I would take that and plug it in right there and solve for x, and you get x equals negative 1. So now we know z, we know x, we need to know y. So you're going to go back up to one of your original equations. It doesn't matter which one you choose, 1, 2, or 3. And you're going to plug in your z and your x. Whoops, sorry about that. You're going to plug in your z or your x, and you're going to solve for y. And again, it doesn't matter which one of the original equations that you substituted into. And we get z equal, or y equals 5. And we want to give it as an ordered triple, x, y, z. And that is your solution. Let's do another one. So you look at this one. The main thing is you have to figure out a plan. Which variable do you want to eliminate? So step 1, we're going to have to get it down to 2 variables. So it looks like we took that equation up here and we multiply it by -5. And we're using equation 1 and 2. Add them together and you notice, whoa, looks like everything cancels out. 0 equals -7. Well, we know that's not true. So, because you get a false equation, there is no solution. Let's do another one. First step, we need to figure out what variable we're going to eliminate. Put it in two equations. So we have x minus y equals -3. So that is equation 1. That is equation 2. Add them together and we eliminate our z's. So we have 2x minus 2y equals -6. Well, we need another equation. So on this one, it looks like we have equation 2 and equation 3. We already have opposite coefficients with the z's, so we don't need to add anything together or multiply anything. Add them together, those z's cancel out. 6x minus 6y equals -18. So now we have two equations. Now we just have to solve that system. Doesn't show the step here, but you have a 6x here. The opposite of that would be -6. You need to multiply that by -3. And if you notice, everything cancels out. And you get 0 equals 0. Well, that's obviously a true statement. So this has infinitely many solutions. All right, this would be a you-do type of problem, so you might want to go ahead and pause. Try these 3 problems out. Then when you're ready, check your answers. So on this one, we've got a word problem. An amphitheater charges $75 a seat in section A, 55 in section B, 30 for the lawn. That's pretty typical. There are 3 times as many seats in section B as A, and the revenue from selling all 23,000 seats is $870,000. All right, so you need to go ahead and set up a system of equations. So the number of seats in B equals 3 times the number of seats in A. That's going to be our first one. Number of seats in A plus number of seats in B plus number of seats in the lawn is going to be the total number, which is 23,000. Now we're going to do one with cost. $75 times A, 55 times the number of seats in B, 30 times the number of seats in the lawn is going to equal the total revenue. Now, write that system. Y equals 3x. X plus y plus z equals 23,000. 75x plus 55y plus 30z equals 870,000. So now we need to write our system in 2 variables. We already know y is 3x. So I'm just substituting that y in 2 equations and putting in 3x in its spot. So now I have two equations with an x and a z. Now we have to write those two equations. It looks like we took that equation right there and multiplied it by negative 30. That way we will eliminate our z's. Negative 30, positive 30. They cancel out. Now you just solve. X is 1500. Well, once you got that first variable, it becomes a lot easier. Substitute that into equation 1, solve for y. We just need to know z. So you're going to plug that back into one of your original equations and solve for z. So that tells you how many of each you have. That's kind of a what if. I'll let you take a second, think about it, check your answer. All right, take a second, think about that. What is a possible first step? And there's going to be more than one answer on this. A sample equation could be rewrite the system in two variables, multiply equation 1 by 2, and you're going to eliminate your y's. I was thinking about eliminating my x's. Again, there's going to be more than one correct answer. All right, we are done. I hope you enjoyed.